Hello everybody, Zero Fossil Fuel. I want to share with you a moment of inspiration I had the other day and hopefully inspire in you some creative thought regarding the creation of a resonant fuel cell. I've always believed that resonance was the key to unlocking the potential of water fuel cells with very high returns for very little energy input. Boyce, Meyer, Lawton, Linderman, and others were all on that same path. Through their experiments, they were all hitting resonance in their water fuel cells by sending it various forms of high-frequency energy. The HHO cell, with parallel metal plates in water, is basically just a capacitor. However, this special capacitor has dielectric breakdown characteristics similar to a Zener diode. Once a certain voltage across the plates is reached, current increases sharply, as shown in the diagram to the right. To create a circuit that has a tuned resonance requires an inductance connected in series or in parallel with the capacitor. This becomes the electronic equivalent of a clock pendulum. Push it lightly at the right time and it swings very easily, requiring very little energy. The fundamental problem with using HHO cells in a resonant tank circuit is that the properties of the capacitance are not fixed like a normal capacitor. In fact, they are wildly dynamic, varying with temperature, impurities, plate spacing, but most importantly, gas production. The moment bubbles start to appear between the plates, the target moves. It's the equivalent of shifting the pendulum weight up and down the swing arm, and the swing rate changing. To keep it going, you then have to change how fast or how slow you push it to time it properly. To hit the resonant sweet spot, Boyce took the shotgun approach with a wide spread of frequencies and harmonics. This is an oscilloscope view of the multiple frequencies and harmonics generated by the triple frequency Boyce cell modulator. Meyer tried to zero in closer by sending the cell repetitive bursts of single frequency energy and catching the resonance as it sweeps through on each burst. Both methods work better than trying to send it a single frequency and hoping to hit it. What's important to note about this diagram, however, is that every part of it is only a functional block diagram. Even the portion that looks like the actual schematic is not. It is merely an oversimplified representation of the concept. It is very unlikely that a single blocking diode in series is the actual method Stanley wired his voltage intensifier circuit. It just doesn't work that way. As such, the wild theories surrounding radiant energy being the source of energy is also somewhat unlikely. Others are now toying with complex phase-locked loop and microprocessors. I personally have a concept on paper to track the cell resonant frequency by frequency modulating the pulse signal slightly and correcting based on phase relationship of the amplitude error signal. That's a mouthful, but I'm going to show you what I mean by that. This graph represents the high impedance voltage relationship of a parallel tank circuit to the right. At the frequency of resonance, the voltage spikes and the current falls off sharply. Let's zoom way in now on the peak of this resonance curve. In this magnified view, Fc is the target injection center frequency for our cell pulse driver circuit. If we frequency modulate that signal, the distance between F1 and F2 represents the total deviation. Notice that the voltage amplitude is equal at both sides. That's how our comparator circuit can sense that the injection frequency is at resonance. If the cell resonance jumps around, as we know it will, the resonant peak will move off center. In this image, the resonant peak went positive. The amplitude of F2 is now greater than that of F1, so the oscillator needs to shift upward to follow it. The circuit knows this because the relationship of the modulation to the amplitude is in phase. As the frequency goes up, the amplitude goes up. If the opposite occurs and the resonant peak tries to drop below the oscillator frequency, the comparator again knows to compensate in the opposite direction because the relationship of the modulation to the amplitude is out of phase. As the frequency goes up, the amplitude goes down. Through the use of comparators and error amplifiers, it should be fairly easy to obtain a lock. With programmable microprocessors, a myriad of other tests can be routinely injected to ensure proper frequency lock. I am quite certain that this method would work. I almost started down this path with my blinders securely fastened until I had a flash of inspiration. You know what? I think we are making this a lot harder than it has to be. I believe we are again victims of misinformation. Either Meyer, Boyce, and the others were agents of this misinformation, or they, like us, are simply victims of it. Think about it for a moment. Let's go back to the pendulum of a clock. It can be made to resonate if we poke it lightly and repeatedly with our finger at the resonant frequency. But is that how the pendulum really operates in a clock mechanism? No. The clock spring does not feed the pendulum pulse energy at its precise resonant frequency. The clock doesn't know what the resonant frequency is. The clock mechanism feeds the pendulum energy when the pendulum asks for it. The pendulum itself sets the optimum frequency for itself. In electronic terms, we call this a regenerative oscillator. Even if the pendulum weight were to shift up and down and the swing rate changes, it still resonates. It's an oscillator. Who cares if it drifts? The question is, why are we messing with ideas on how to force the resonant tank circuit of a cell and inductor to do something that it wants to do naturally anyway, and worry about figuring out ways to track it as the dynamics of the cell changes? I say, let the tank circuit itself set the frequency. Let the tank circuit be part of a regenerative power oscillator. Sample a portion of the energy, amplify it, and feed it back into the tank circuit in phase to sustain oscillation. Let it step charge the cell until it reaches the catastrophic dielectric failure over and over. It doesn't matter how the dynamics of the cell changes. It will constantly be at its own natural resonant frequency, no matter what the conditions change in the cell. It wants to be an oscillator. Let's set it free. Now, this diagram is just a crude representation of my thought process. It may or may not work as drawn. In fact, it probably won't, but you get an idea of the direction that I'm going with this theory. I still need to work out the details, obviously, but I make no copyright claims to anything contained in any of this material. If it inspires something in you, please build it and give it a try. I, too, will be working on this circuit today, July 4th, 2008, Independence Day here in the United States of America. If it works, as I think it might, this might truly become the Independence Day of all Independence Day for all humanity, for all eternity. I think that's enough for now. Zero Fossil Fuel signing out. Everyone be well, be safe, have a happy holiday, and get building.